Okay, these are in the test folder, so some review by me. You can also do the My Math Lab review if you prefer that. So, so if we look at this, what is problem solving is kind of hard. So guess and test is a good strategy. Doing an easier problem, making a chart, looking for a pattern. Those are all good strategies. So this one, it says the sum of the 8th row, consider the 4th row. Okay, so what I really care about is the adding of the rows. I don't even really care what the rows are. There is a pattern here though. I don't know if you see it, but like 1 and 2 make 3, 2 and 1 make 3, the ones come down. So like down here, 1 and 3 make 4, 3 and 3 make 6, and then, you know, basically kind of 1 and 0 come down. So that's where the 1 comes from, and then the 5, the 10, the other 10, the 5 and the 1. So I could keep going down in the pattern. And this is the 0 row, 1 row, 2 row, 3 row, 4 row, 5, 6, 7, 8, and do that. But I just care about the sums. So I'm going to look at the sum. Sum means to add. So I'm just adding these rows. And right away, when I add them, I'm like, ooh, I see 2, 4, 8, thinking maybe this is 16, right? Which that looks like it's true. 32. So it looks like I can just keep doubling all the time. So this is my 0 row. So 1, 2, 3, 4. This is my 5th row. So then my 6th row would be what? 64 and 128. So this is 6th row, 7th row. So 8th row looks like it's 256. So 8th would be, there'd be 200, or the sum of that row would be 256. And again, if you wrote it out and added it, you get the same thing. And the reason I called this the 0 row and this 1st row, 2nd, so that the exponents would match. This is 2 to the 0 power, 2 to the 1, 2 squared, 2 cubed. So if you realize they were powers of 2, you would be like, okay, the 8th row is going to be 2 to the 8th, whatever that is, okay? All right, here, look at the pattern. And on these, I try to connect the number to like, how does the 1 represent itself? Where's the 2 at? Where's the 3 at? So it looks like the 1 is your bottom row, the 2 is your bottom row, the 3 is your bottom row. So the 6th bottom row is obviously going to have 6 in it if the pattern continues. So 1, 2, 3, 4, 5, 6. So 6 would have 6 in the bottom row, right? And then there's 1 less going up because it kind of overlaps. So this would be 5 going up. 1, 2, 3, 4, 5, 6. Okay, I didn't quite draw that to scale. Draw a picture. How many blocks are in the 100th number? Okay, well, the 100th number would have 100 blocks here, but then we don't double count, right? Like this block is counted twice. So this would be 99 up here with 1 there. So there'd be 199 in there. So again, just kind of looking at like, ooh, the 3rd seems to mean there's 3 down here or something like that, looking for a visual pattern. All right, here, a car rents for $220 per week plus 25 cents a mile. Okay, so we have a rental, the kind of the fee, and then we also have the 25 cents per mile. Okay, the rental cost for a 2-week trip. Okay, so this is the car rents for $220 per week. So I'm going to have to double that because I'm renting it for 2 weeks. And then what? We have the mileage, so 500. So I'm going to take the price per mile times the number of miles, right? And so this is kind of the mileage fee. All right, so I'm just going to take my calculator. If you have a calculator that does order of operations, you should be able to type it just in. If you don't, you might have to do the 2 parts separately. All right, so I got, does that seem right? Yeah, $565. Okay, all right, so this is 440 over here. The easy way to take 25% of something, or 0.25, is take half, which would be, what, 250, and then half again to get a 4th. So that'd be $1.25. So is that right? 440 and 125. Yep, seems like it's reasonable. All right, which is a better value, 12 ounces of honey for that, or 18? The way I always remember is money's more expensive or more important than the honey. So you always, on your calculator, you put the money first, the ounces separate. So money first. And I actually did this at the store the other day because I was debating between literally this, the 12 ounce and the 18 ounce. All right. So again, money's more important. So that's what you type in your calculator first. Divide by 12. So this guy's, and again, you might not want to round right away. Okay, that's the price per ounce. And again, write a bunch of decimals because sometimes these are so close, like they're not a huge difference. And this one's 18 cents, yeah, per ounce. All right, so which one's cheaper? Well, it looks like this guy is. Not always. Sometimes bulk is more expensive. So this one's cheaper. And then another way to do this is actually how I do it in a grocery store. I'll be like, ooh, 3 of these would equal 36 ounces, 2 of those. So because sometimes I can do that in my head. So if I have 12 ounces for what, $2.25, if I scale it by 3, I can get 36 ounces for what is that? $6.75. And again, you can use a calculator. And then I scale the other one up in my head in the store. So I'll be like, okay, 18 goes with that. So if I double it, scale it, I get what, 648. I can usually do that math in my head without a calculator. So then it looks like, okay, this is 648 for 36 ounces. This is 675. So again, this one's cheaper. So you can either get the price per ounce or sometimes you can scale them up to get the same ounces and then kind of do that. All right, say you have 50-cent coupon off any 12 ounce or larger. Which jar is better value? Okay, so I can use a coupon, what, on either one of them? All right, so if I have $2.25 and I've got, what is it, a 50-cent coupon? Yep, 50 cents. And then over here, I have my is it 320? I can't read. Did I cover that up? Was that 324? Yeah, 324 minus 50 cents. All right, and again, if you want to use a calculator, go for it. Doesn't bother me. All right, so this is $1.75. But again, remember, we're going to divide it by what? This one's what, 12 ounces? Okay, so I'm just going to go ahead and divide that right away. And again, money's more important than ounces. All right, so this one becomes that, give or take a little bit. That's your price per ounce. Here, I'm going to subtract 324 minus my 50-cent coupon. Minus 50 cents, right? And again, I'm just typing that in. And I get $2.74. And then again, money is more important than ounces. So put the money in your calculator first and divide by ounces second. So that's something like that. Okay, so now this one's cheaper. And people that are into couponing usually say buy the smallest because that coupon is a bigger percent off. So sometimes they'll go dumpster diving to get a bunch of coupons. So they will just buy a bunch of honey and use a bunch of coupons versus buying the bigger size because then your price per ounce is usually less. Not always. You have to do the math. Okay, here someone earns $48,000. Another earns $3,750 per month. How much more? So again, I want to know the difference between the two salaries. How much more does one person make than the other? All right. So first, let's compare apples to apples. Assuming they work 12 months here. So I have 3,750 times 12 months. And again, just typing it in my calculator. All right. So this person actually makes $45,000 a year. And the other one makes $48,000. And again, one definition of subtraction is like 5 minus 2. Like I have 5 cookies and I eat 2 of them. How many cookies are left? Kind of a takeaway idea. But the other definition of subtraction is the difference. So if you kind of think of a number line, like here, this person makes $45K. This person makes $48K. What's the difference between them? You're not taking that person's salary away from this person. You're just saying how far apart. It's like more of a distance definition. That's also subtraction. So if I take 48,000 minus 43, that's what? A $3,000 difference in salary. Okay. All right, let's keep looking. Let's go to the next page. And again, these are ones that I posted in the exam folder. All right, magic squares are in some of your homework. Basically, every row, column, diagonal adds up to the same. So do you see how I give you that diagonal? So you should be able to figure that one out. So let's do 96 plus 43 plus 25 plus 78. Oopsie. All right, so it looks like 242. So 242 is the total. So then what you can do is, like on the rows that you have 3, I can subtract. So 242 minus the 82 minus the 78 minus the 23. Okay, it looks like that one's 59. Where else can I go? Oh, this one I know 3. So I know the total. So 200, I'm going to clear. There's a broken screen there. 242 minus the 96 minus the 37. Yep, minus 45. Some of these keys kind of stick. That's 64. And now notice I know these 3. So I can take 242. What do I have? Minus 64 minus 43. Minus 59, that's 76. And then I can keep going. I know those 3, so I can subtract to get that guy. And then I'll know these 3, I can subtract to get that guy. I know these 3, I can subtract to get that guy, and then I can finish up. All right, let's look at the next one. Days of the week. Roster method is when you use little curly things, right? So this would be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and then Saturday. And then we do it all over again. All right. How would you write set notation for all the natural numbers less than 8 using set builder notation? Okay, so set builder notation, zoom in a little bit here. Set builder notation is where you do like the little curly thing, and then you define your variable. So my x is an element of the natural numbers. I'm just going to use a big N for that. Such that you draw a line, and you put your rule over here. So I want what? Less than 8. So all of them, okay, so not less than or equal to, just less than 8. And do that. So you do define your variable, x is an element of the natural numbers, such that, and then you put your rule over here. All right, how would you write set notation for all the natural numbers less than 8 using the roster method? All right, whole numbers include 0. Natural numbers do not. Natural numbers are the counting numbers. So like how, as a little kid when you first learned to count. 4, 5, 6, and 8 is not included because it said less than. And 0 is not included because it's not a whole number, it's a natural number. So this would be roster. Okay, if if set W is the days of the week, what is this? Okay, so what is the cardinality, or how many sets, or how many elements are in the set week? Well, 1, 2, 3, 4, 5, 6, 7, right? There are 7 days of the week, so that's called cardinality. That set has 7 elements. All right, true, false. Let's see, is 1, 2, 3, 4 equal to that? And false because they don't have the same elements. Is 3 an element of that? Nope, because it's not on the list, so that's false. Is A, B, C, D a subset of A, B, C? Remember, this is kind of like 7 is less than or equal to 8. The big thing has to be to the right, and the smaller has to be to the left, or equal in this case, because it can't equal it. All right, so here the big set is A, B, C, and my set is A, B, C, D. So do you see how my set goes outside? It's not a subset, so that is false. All right, knots, double knots get a little tricky here. So trying to focus a little better. So what I do is I get rid of the knot. So I ask myself, is 5 an element of 5, 6, 7? And the answer would be true, right? But this says 5 is not an element. So that's going to be false because it is an element. Okay, so 5 is an element. That's true, but this says 5 is not an element. So that would be false. Right, the empty set is always a subset of every set. That is true. Remember that if you have like a set AB, remember A is a subset, B is a subset, all of it is a subset of itself. And then the air or the empty set, right, is another subset. So just know the empty set is always a subset. And then here, that's not again. And notice there's no line. So this is like 7 is less than 8. This is a proper subset. All right, so I'm going to get rid of that symbol for a second. So let's pretend it's this. Is 1214 less than 1214? And the answer is no. Okay, that is false. So this would be true. Okay, and again, the reason it's not is because this is saying that it's less than, and 1214 is, the same thing, 1214. So it's not less than it, it's equal to it. So that's why that's true. All right, because it has that no in there. All right, how are we doing on time? All right, let's look at the next page. Find again, this is cardinality, so the number of elements in A, okay? So this is multiple choice here. Find, and X is the numbers on the clock of face. Okay, so if you think of a clock, it has 12, 1, 2, 3, 4, all the way around, right? Okay, so there are 12 numbers, so the set would have 12 elements. Okay, determine whether the sets are equal, equivalent. Okay, so these are not the same. This is 13 because there's no comma. So they're definitely not equal. Equivalent means they have to have a one-to-one correspondence. So like this corresponds to that, but do you see how that 3 has, nobody to correspond to? So they're not equivalent. Can't be both, so definitely neither. Find the cardinality of the number of set A vowels in the major river. Okay, so if you're like, I don't know the major river, it is Mississippi. Mississippi. All right, that's how you spell Mississippi. But be careful the number of vowels. All right, so the number of vowels, you might be like, ooh, there's 1, 2, 3. There's all these 4 vowels. The set, remember, we don't do repeats, so the only vowels are I. So the cardinality is 1. It doesn't matter that there's 4 of them. It's just that there is 1 vowel. Okay? All right. And then I think I'm about running out of time. So I'm going to stop the video there. And then we'll finish this one and hopefully start a little bit on that guy. And also I added a review over logic. So